Hello dear students, I welcome you all to my channel. So let us begin with the very new chapter, that is chapter 12. So the name of the chapter is Midpoint Theorem and its converse. Okay, so today we'll just get introduced with the theorems that we are going to learn in this particular chapter. Alright, so from the next class onwards we'll see the exercise. So the first theorem that we are going to learn here is midpoint theorem. Alright, so midpoint theorem says the line segment joining the midpoints of any two sides of a triangle is parallel to third side and is equal to half of it. Now it's very difficult to understand just this statement. Alright, so let us try to understand this statement using the figure. Alright, so I have taken a triangle ABC. Alright, so questions or my theorem says the line segment joining the midpoints of any two sides of the triangle. So I am taking any two sides. I am taking AB and AC only, and I am taking their midpoints. Alright, so let me take X to be the midpoint of AB and Y to be the midpoint of AC. Alright, now the line segment joining the midpoints, that means the line segment means we have to join X and Y. Alright, so this is the line segment the theorem is talking about. Alright, so this line segment is parallel to the third side. So this is one side, this is another side, and which one is third side? This is my third side. Alright, so this line is going to be parallel to the third side, and this line segment is going to be just half of the third side. Alright, so suppose if BC is 10 centimeter, then this XY has to be 5 centimeters. So that's what the theorem says. Alright, so it is given that X and Y are midpoints of AB and AC here, right? So if this happens, then XY has to be parallel to BC. That's what the theorem says. This is the first point, and the second point is XY has to be the half of BC. Alright, so this is all about your midpoint theorem. So you may pause the video to note down. Okay, now let's have a look at another theorem, and name of the theorem is converse of midpoint theorem. So the statement goes like this: the straight line drawn through the midpoint of one side, this is not one point, please cut this part, so one side of a triangle parallel to another bisects the third side. Again, reading the statement doesn't make any sense here, so let's try to understand this using diagram. So I have taken triangle ABC, and here they are talking about midpoint of any one side. Alright, so let me take this side AB and let me take the midpoint to be X here. Alright, now from X we have to draw parallel line. Okay, so it can be parallel to either BC or it can be parallel to AC as well. So let me draw a line parallel to BC here. Alright, so in this way I am drawing parallel line. So as I said, this line is parallel to this line. Alright, so let me name this point to be Y. Alright, now according to theorem, see here, so in the theorem it was said that we have to take one midpoint of one side. Alright, and from that point we have to take one parallel line. That parallel line also I have taken. Alright, now according to theorem, if these two things happens, then this parallel line bisects the third side. So I have already made use of this side, I have made use of this side. Alright, so the third side means this is the third side. Alright, so this third side will get bisected. So bisected means AY and YC both will be equal, or in other words I can say Y is the midpoint of AC. Alright, so that's what is written out here. So given X is the midpoint of side AB and XY is parallel to BC. Okay, so then what happens? Then AY will be equals to YC. So that's what is the meaning of converse of midpoint theorem. So you may pause the video to note down. Okay, so the third theorem that we are going to learn in this particular chapter is called equal intercept theorem. Now this particular theorem will be used in our second exercise of the chapter. Alright, but before only we'll get introduced with this theorem as well. Alright, so the name of the theorem is equal intercept theorem. Now here intercept is nothing but a distance which is cut by some set of lines. Alright, so we'll try to understand this using diagram later on. So let us read out the statement. So statement says, if a transversal makes equal intercepts on 3 or more parallel lines, then any other line cutting them will also make equal intercepts. Again, reading only doesn't make any sense here. Alright, so let us take some parallel lines here. Alright, so here the minimum has to be 3. Alright, so you can take more than 3 as well, but here I am taking only 3 parallel lines and I am writing them as L1, L2 and L3. You know the meaning of this arrow, right? This arrow means that the lines are parallel. Okay, now I have taken parallel lines. Now you have to take transversal. Okay, so I have taken a transversal. I am naming it to be T1. Alright, now let us take A, B and C to be the point of intersections, that is this point and this point. Now here what is happening is this line is cutting equal intercepts, right? So that's what is written here. So if a transversal makes equal intercepts on 3 parallel lines, so equal intercept means here this line, this or this portion, that is AB. Okay, so this is one of the intercept and another intercept is BC. Alright, so here basically according to theorem, AB and BC must be equal. Alright, so if AB and BC is equal here, then if I take another transversal, then the intercepts made here are XY and YZ, isn't it? Now if AB and BC are equal, then this another line will also make equal intercepts. That means this XY and YZ must also be equal. So that's what is the meaning here. So let L1, L2 and L3 be 3 parallel lines. As you can see from the diagram, I am considering 2 transversals, that T1 and T2. So T1 and T2 are 2 transversals here. Alright, so then if AB is equals to BC, as I said, if these 2 intercepts are equal, then the another set of intercept, that is XY and YZ, they also need to be equal. So that's what is the meaning of equal intercept theorem. So you may pause the video to note down the theorem. Thank you very much.